Assalamualaikum and hello everyone. I am Rafiq Shukri bin Zulkifli from Malaysian Japan International Institute of Technology, and I will explain about my FYP project, which is entropy based local binary pattern on HSV color model for face recognition. In this era of technology, more and more technology are being introduced to make people's life easier. The gadgets, especially nowadays, have more complex and more functionality compared to last decade. One thing that fascinates me is most latest generation of smartphones have facial recognition technology. It is a powerful and a useful technology as in daily life because it is give a more faster and need almost zero effort from the subject to log into the phone or into any software in the phone. Facial recognition are also being used worldwide, especially in the airlines boarding, border check between states, Mastercard selfie, hotel check-in, and also when making an entrance at the events in some of the countries. This technology is so powerful that it takes 2 seconds in average, which is really quick compared to the regular way. And also, it is successfully reduced the time of, of the check-in by more than 40% compared to the regular ways in the airlines boarding. Furthermore, a lot of large tech companies are working on this facial recognition technology, such as Facebook, Google, Amazon, and Microsoft. Thus, we can imagine in the next few years, more events will be using face recognition technology. Have you ever have this problem? It is normal. While face recognition are starting to being used more widely, there are a few improvements that needs to be done. The situation where in the different illumination, different face expression, and a different color skin of the person will affect the successfulness of the face recognition. This is when I think on how to improve the facial recognition so that it will always working no matter the lighting, no matter the skin color of the person, and also no matter what is the expression of the person. So how the system is being done? For my case, I will be using MATLAB in most of my project. The system is being done by calculating the entropy and local binary person and local binary pattern LBP by using a given color model of a person. By having a few reading about the facial recognition, I found out there are a few color code that needs to be considered in making the facial recognition. The main color code that need to be considered is RGB, which is red, green, blue, and also HSV, which is hue, saturation, and value color code. So by the few further readings, there are an experiment that have been done before, and the result is HSV, hue, saturation, value color code, will give more accurate data, especially for human skin. So the method that I done in this research is by using these three color code or color channel, which is hue, saturation, and value color channel. After the original image were divided into three color channel, the image is then divided further into small region. This is to ensure that we have more detailed data and also to determine the part of the face that have high entropy. In this project, the image is divided to 6 by 6, 12 by 12, and also 18 by 18. And after that, the image will compare to find the best number of blocks that needs to be divided. So from the observation of the entropy obtained from the image that were divided, the more region that is the image is divided, the more detailed the data obtained, which is for my case 18 by 18 is giving more detailed data compared to 6 by 6 and 12 by 12 as shown on the entropy image. The entropy was calculated and later by using linear binary patterns LBP, the data is tallied to the entropy obtained. From the image of the entropy, the red part of the entropy, which is more than 5, indicating the high entropy area, while the blue part is low entropy area of the image. The entropy here is mean that part of the image having a more information compared to the blue part. So the threshold of 5 that were taken here is because it shows a better result and also will make the observation of the image is more clear. So from the three color channel, hue, saturation and value, this is the image obtained when the image is divided into three color channel. From this three color channel, we can plot a histogram of a pixel value. From the histogram, we can see that the hue image is mainly a hue image. It consists of almost all dark color. So the histogram will show the pixel value. It tends to shift to the left, indicates a more darker pixel color compared to the value images. The brighter the color, the more the histogram to shift to the right. And also the maximum value of the pixel is 255, which is a pure white color. So from this LBP of the images from hue, saturation and value, it is then combined to form a long histogram. This is the process compulsory to train the image. With this long histogram, the entropy which will give the histogram a weightage and will be embedded into the histogram. The new histogram obtained is more focused on the middle as the entropy in the middle is much more higher compared to the entropy on the side part. The process of combining and also embedding of the entropy will be repeated for all the training images. The training phase is being done using 50 different images with 50 different percent. For the testing of the data, these 10 images were selected randomly from the database. This 10 image is a different image from the training phase, but it is the same person as in the training phase. Our objective is for the system to recognize the image and tell us if the testing image is the right one from the training image. From 10 image, the level of confidence of all the image from testing to its respective image from the training is quite high, which is all is more than 90%. But this does not mean that the system is able to recognize perfectly the image as correctly as in image 1. Even though the level of accuracy is 96%, the image recognized is false, as the image recognized as different image from training image, which means there are other image that receive a higher than 96% than the one that is supposedly to receive the highest accuracy. This project will help the future of facial recognition by ensuring the successfulness of each facial recognition even in dim light. The facial expression and the skin color of the person Facial recognition can further gain acknowledgement as major piece of security such as in law enforcement agency which uses gadgets in facial recognition to spot criminal and also in CCTV to widen the surveillance capabilities and also to make the tracking of the footage to reach criminal faster. Apart from that, in the near future, there will be more and more facial recognition feature system, whether paying online, opening bank account or going through the security point in the airport, as the human face is already a perfect source of data similar to thumbprint. That's all from me. Thank you for watching.